Hello everybody. So what we're going to be doing today is the chain rule. So chain rule is a nice, easy, short lecture. Thankfully, the last lecture we had was trig integrals, and they're not hard, but there's 6 of them that you have to practice. The chain rule is going to be significantly quicker, I think. I'm usually wrong, but we'll see. So here's the thing. You know that you have a rule for, you have rules already for sums of functions. I'm talking about derivatives, right? So you have a rule for sums like d dx f plus g. That's f prime plus g prime. I'm using shorthand because I'm lazy. You have a rule for products, d dx. That was supposed to be parentheses. Try again. Fg, right? You have the product rule, f prime g plus f g prime. You have a quotient rule. Quotients, I'll just say. d dx f over g, f prime g minus f g prime over g squared. But you may or may not have noticed that we did not have a rule for functions in functions. So the chain rule shows us how to evaluate the derivative of a function in a function. All right. So let me just double check something real quick. One moment. Interesting. Okay, let's get back to this. Okay, so chain rule shows how to evaluate the derivative of a function in a function. So the formula that you're going to need can be written in a couple different ways. So here they are. So chain rule. So one way you'll see it is they'll say the derivative with respect to, we'll say x, of f of g of x, I have a lot of parentheses there, is you take the derivative of the outside function, f prime, you leave the inside function, g, alone, and then at the end, you multiply by g prime. And that's why they call it the chain rule, because this is like, this part is chained onto the end. All right, there's other ways to write this. Another way to write it would be something like this. d dx of, what am I even going to write? Let's see, f of u, like that. And you would say that it's df du times du dx. And so this is your f prime from up above, and then this is your g prime from up above. And generally we're going to be using the first one, the first set of formulas there, and yeah, I mean, that's what we're normally going to be doing. Let's see some examples so I can actually show you how this works in practice. So the idea is going to be this. So whenever you have the derivative of, let's say, a function in a function, so like here, the derivative of sine x cubed, right? So you have an inside function and you have an outside function. So that's outside function, and then you have an inside function. And what you do to evaluate that derivative is, first you take the derivative of the outside function. So the outside function is sine. Well, sine of what, right? So what's the derivative of the sine function? You have to remember to the previous lecture, it is the cosine. inside that, you leave the x cubed alone. So we took the derivative, right? That's the derivative, but that's the same as it was, right? Sine went to cosine, x cubed stayed x cubed. But onto this, you multiply by the derivative of x cubed. So what's the derivative of x cubed? 3x squared, right? Let me take this off. So you take the derivative of the outside function, and here you multiply by the derivative of the inside function. And that's it. That's the chain rule. Okay, now you don't really want to think of it, I don't know, you don't want to think too hard about it, I should say. So let me do a different one real quick so I can, actually let's do the same one because I want to give you an idea about something. What I like to do in my head is just kind of number the functions from the outside in. So like this is the outside function, and then this is the inside function. And so what I do is I know that the result is going to be the derivative of 1, and then you're just going to multiply by the derivative of 2. That's it. So you're just going to do them in order. So the derivative of sine is cosine. Hardest part is remembering to keep the inside the same. Then times the derivative of 2. Well, the derivative of the inside is simply 3x squared. So you don't have to think that hard about it. You just kind of work from the outside in. Let's look at another one. Let's not do a sine again. We just did a sine. Let's do this. Let's change the variable just because. And let's also have, let's see, t to the 4th plus 5t squared to the 6th. Okay, and we want to take the derivative there with respect to t. So again, I'm going to advise that you just kind of in your head number the functions from the inside out. So the outside function is actually this 6th exponent, okay, like something to the 6th. And your inside function is this little polynomial here. So when you take the derivative, again, it's going to be, you take the derivative of 1 first, and then you multiply by the derivative of 2. So how do you take the derivative of something to the 6th power? Well, what you do is you take the power down in front. And then you subtract 1 from the power, right? So something to the 6th, like the derivative of x to the 6th is 6x to the 5th. Well, it's not x. Here it's t to the 4th plus 5t squared, but it'll be 6 that to the 5th. That's the derivative. Now, to the chain rule part, you have to multiply by the derivative of what's inside. So what's the derivative of what's inside? Well, we've got t to the 4th plus 5t squared. So the derivative is 4t cubed plus 10t. There you go. That's it. That's your derivative. Okay. So these are not so bad. You just need to know, work from the outside in. Let's do another one. You can even do functions in functions in functions. That's not a problem. So if I have to do the derivative of, I'm trying to think of one here. Let's say we have to do the derivative of tangent to the 3rd of, we're doing d dx. So let's say square root, no. Yeah, let's just, I was going to say square root x, but let's write it x to the 1/2. And then let's do that derivative. Okay, so this one's a little bit harder. One of the reasons it's harder is you have to identify the outside function. And so before we do the derivative, if you don't already know this, you want to think of it as you've got tangent cubed here. So the outside function is actually cubed. And then inside you have a tangent. And then inside that you have x to the 1/2. So I've got actually a lot of functions here to deal with. And let's number them. So the outside function is that cube. Inside of the cubing function is the tangent. Inside the tangent is x to the 1/2, right? So there's a function in a function in a function, right? It's a cube and then a tangent and then an x to the 1/2. And then you go to take that derivative, and we take the derivative. Again, we're going to have a first derivative, and then we're going to have a second one, and then we're going to have a third one because we're doing 3 chained. So the derivative of something to the third is 3 something squared. What's inside? The same thing that was inside. So tangent to the 1/2. Then you have to multiply by the derivative of what's inside that. So the derivative of the tangent function is next. What's the derivative of tangent? You have to remember from the trig function lecture. The derivative of tangent is secant squared. So this is secant squared x to the 1/2. Okay, well now you have to multiply by the derivative of what's inside that. So what's the derivative of x to the 1/2? It's power rule. It's 1/2 x to the negative 1/2. Okay, so 3 functions, so 3 derivatives, and you do them in order. Now we can write this maybe a little bit better. It's not gonna, I mean, we're not gonna be able to do too good of a job here, but we'll try. So let's say 3, I'm just simplifying. 3 tangent squared, x to the 1/2. I'm gonna write x to the 1/2 as square root x. I didn't write it that way at the beginning, but it is. And then I've got secant squared x to the 1/2, so secant squared square root x. Then I got a fraction. This right here, there's a 2 in the denominator, right, because 1/2. And then x to the negative 1/2 is x to the 1/2 in the denominator, so that's a square root of x there. So that's a pretty complicated looking derivative, right? We would not have been able to do that until we learned about the chain rule. It just really doesn't want to let me put a box around this. Okay. So we would not have been able to do that without having the chain rule. Okay. Now you are going to have to do things like product rule and that kind of stuff. So like here's an example. Given h is negative 3x plus 2 to the 4th, negative 2x plus 3 to the 3, find h prime. Okay, so here's what you would do. So we need the derivative, but what you should recognize first is that we have 2 functions multiplied, right? This function is multiplied by this function. That means we're not doing chain rule right from the beginning. From the beginning, we're doing the product rule. So the product rule, which we already wrote once, but remember the product rule, where can I write it? Over here. Like fg prime is f prime g plus fg prime. So I'm just going to write it out. F prime g plus f g prime. Right? And I have 2 derivatives left to take now. So that was product rule. Now I've got a derivative here that I have to take, and I have a derivative here I have to take. Okay, so we have 2 derivatives there to take, 2 smaller derivatives, and each of those is going to need the chain rule. Take the 2 smaller derivatives, use chain rule as appropriate. So it's not going to be bad. So I'm looking at this one right here, and I see it's something to the fourth power, right? So like this is my first function, and then this inside is my second one. So the derivative of something to the fourth power is 4 that thing to the third, right? That's my derivative of 1. You multiply by the derivative of the inside. So what's the derivative of negative 3x plus 2? The derivative of negative 3x plus 2 is just negative 3. So there you go. Then you've got this negative 2x plus 3 cubed. That's fine. No derivative there. Plus, I've got parentheses, negative 3x plus 2 to the fourth. No derivative there, so just write it again. And then for that last derivative, again, outside function, inside function. So that means chain rule. So the derivative of the outside function is something cubed. So we know that it's 3 something to the 2, right? That's my outside derivative. Then my inside derivative is the derivative of what's inside. So what's the derivative of negative 2x plus 3? Simply negative 2. Well, that's it. We're done. There's not a lot. Well, I was going to say there's not a lot you can do. Probably what I would do here is I would say, like, if I'm trying to figure out what I can take out of this, like I'm looking for a lot of like terms, right? Like this has a 2. Oh man, I want to highlight. Like there's a 2 right there, and this one has a 2 inside the 4. So but they both have a 2. And then this one has a 3, and this one has a 3. So I can probably take out a 6, right? Because they both have a 2 and a 3. And then what else do they have in common? They both have a negative 3x plus 2 to the 3, right? This one has it over here, but it's to the fourth, but I can take out 3 of them for sure. And then the last term, here and here, I have negative 2x plus 3 squared and negative 2x plus 3 cubed, so they both have 2 of them, so I can take out 2 of them like that. Now let's see what we'll have left. So in this first part right here, I took out a 6 and a 2, but there was actually a negative 12 for the coefficient. So if it was negative 12 and I took out 6, there's still a negative 2. And then I left one of these in there. How are both of the, hold on. No, I didn't take, I took all of those out. That's wrong. That's wrong. Right, I took out 3, and there were 3, so I took out all of them. And then what I didn't take out was one of the negative 2x plus 3's, right? Because there's 3 and 2, and I took out 2. Okay, and then plus, on this other one, I took out a I took out a 6. There was a negative 6, so I guess technically I have a minus. And then what else? I left one of these negative 3x plus 2's, and that's it. So I got, yeah, I'm going to take out a negative actually. Negative 6, negative 3x plus 2 cubed, negative 2x plus 3 squared. I took out another negative, so what do I have here? I have 2 times negative 2x plus 3, so that's going to be, if I cover up the 2, sorry, cover up the minus, I have minus 4x plus 6, I wish I hadn't taken out the minus, minus 3x, I'm going to retroactively put that back, and then I'm going to redo this. Okay, so what do I have? Negative 2 times negative 2x, that's 4x. Negative 2 times 3, that's negative 6. Then I have minus minus 3x, that's plus 3x. And then minus 2, which is minus 2. So I have 6. Negative 3x plus 2 cubed. Negative 2x plus 3 squared. And then here I have 4x plus 3x, which is 7x, minus 8. Okay, there we go. Did I have to do that? Absolutely not. I could have, like, basically here I'm done. All I really had to do was, like, combine the 3 and the 4 and combine the negative 2 and the 3. That would have been perfectly fine. But this is a little bit more concise, so we like that better. What was the point of this? Point is, you can do product rule and chain rule together, and it is what it is. By the way, the one that I boxed is the solution on the homework, so they did that. All right, next thing. So something else you should be able to do is, if they give you a table of values, we should be able to make sense of it. So, like, here's a weird, not weird, but a problem. So they gave us a table. They're giving me a table here of, they have x, and they're telling me f of x, g of x. I should put these all in first before I start talking about things. 1, 2, 3, 4, 5, one more, 6. Okay, so f, g, h, f prime, g prime, h prime, and my x values are negative 2, 2, 4. Put this like this. Put this like this. Might as well do this. Why not? Okay, good enough. So f, what do we have? We have 6 minus 7 minus 7, negative 5, 4, 7, 2, 4, 8, 2 minus 4 minus 2, 8 minus 1, 1, 1 minus 8, 2. Okay. So, this is a table of values, obviously, right? Now, what they want is, they say, given that k of x is f of g of h, so they have function in function in function, they want find k prime of negative 2, right? So in order to do this, you need to know how to take the derivative of a function in a function in a function, which is great because we already talked about that, right? So number the functions from the outside in. So this is the outside, this is inside, h is inside of that. So if I want k prime of x, so I'm not putting in the negative 2 yet, just k prime of x, right? What do? You take the derivative of the first, you take the derivative of the second, you take the derivative of the third. So I didn't really need that much space. What's the derivative of f, right? F is the outside function. What's the derivative of f? We don't know what it is, so you just write f prime. Leave the inside alone. So just g of h. So now you multiply by the inside. So you multiply by the derivative of g, right? What's the derivative of g? G prime. What's inside? H, because that's what was inside it. That's what's inside g. All right, that's it. All right, what's next? Function 3. Function 3 is h. What's the derivative of h? H prime. What's inside it? X. So that's it. Okay, so derivative of f, derivative of g, derivative of h, that's it. There's no more chain to chain. So that's the chain rule. Now, what are we supposed to do with it? We are plugging in negative 2. So we need k prime of negative 2, which is f prime of g of h of negative 2. Hope that's enough parentheses. Then I have g prime of h of negative 2. And then I have h prime of negative 2. All right. Now here's what you have to do. You have to start working this out from the inside out. So with what's listed right there, I should be able to figure out h of negative 2, h of negative 2, and h prime of negative 2. Those are the ones that I could work out right now. So I have f prime of g of what? Right? What are we going to replace h of negative 2 with? Well, you just look up here. Where's h of negative 2? H of negative 2 is right here, right? Because this is the x value. So h of negative 2 is 2. So I come down here and I say, well, that's 2. Then I have g prime of h of negative 2, but we just looked that up, right? That's 2. And then I have h prime of negative 2. Well, what's h prime of negative 2? I actually want to kind of erase that. Put a different color. So what's h prime of negative 2? Well, let's look up here. So h prime of negative 2 is here, right? That's where h prime of negative 2 would be, and it's a 1. So I come down here and say that is 1. Okay, well now you want two things. You want this, we can look this up, and also this, we can look this up. So we can look up both of those things that I underlined. So we're going to have f prime of g of 2. Well, what's g of 2? G of 2, we find it, like 2's right here. So where's g of 2? I guess it's 4, right? So that's 4. Then you need g prime of 2. Where's g prime of 2? G prime of 2 is over here. It's negative 1. So I have negative 1, and then I have 1. Okay. Now what's left, what's left is I've got f prime of 4. Where's f prime of 4? So I come up here, 4 is down at the bottom row, right? 4. Where's f prime of 4? Here, negative 2. So that's negative 2 times negative 1 times 1. So what is that? That looks like 2. Positive 2. Right? So you write out what the chain rule says, right? Chain rule says this. And then you just start looking them up here after you plug in. Start looking up numbers in the table. From the inside out is how you do that. Okay, so that is 2. Amazing, got it right. All right, not doing another one of those because it took a little while and we got more problems to work on. I think we have more problems to work on. Okay, yeah, let's do a quotient rule problem just for practice here. H equals negative 2x plus 4 to the 7. 3x minus 5 is what it should be. 3x minus 5 to the 5. And we want, of course, just h prime. All right. So we have to know the quotient rule. That's a product. We have to know the quotient rule. F prime g minus fg prime over g squared. Okay? So for purposes of the quotient rule, up on top is our f and on bottom is our g. Right? So this is g and this is f for purposes of the quotient rule. So if we're writing out what the quotient rule says for this problem, right? quotient rule. So we're not using the chain rule yet. We're using the quotient rule because it's a quotient. So f prime, that's f prime, I'm going to run out of room, I can see it, g minus f g prime. I'm going to try to move this. Sort of worked, sort of didn't. Where can this go? Okay, right there. So there's my top of the quotient rule. Bottom of the quotient rule is g squared, so that's 3x minus 5 to the 5th parentheses squared. So I've got two derivatives to do here. This one and one over here, right? The two things with the prime on it. Now, in order to do those derivatives, that's where we use chain rule. Chain rule for these derivatives. So let's see if we can do this. That should have been prime. Let's see if we can do this a little bit nicer. Oh, come on, you're in the way again. Just go. All right, so let's see if we can do this a little bit faster. So when you take the derivative of this term right here, what you're gonna do is, you see it's something to the 7th. So you go 7 parentheses, negative 2x plus 4 to the 6th, and then just times what's the derivative of what's inside. So what's the derivative of negative 2x plus 4? Just negative 2. Then you've got 3x minus 5 to the 5 minus negative 2x plus 4 to the 7th. No derivative there, so I'm just recopying it. And then we've got the other one that's highlighted. So we got this. So something to the 5th. So it's going to be 5, 3x minus 5 to the 4th, and then multiply by the derivative of what's inside. So the derivative of what's inside is simply 3, right? And in the denominator, there's not a lot you can do in the denominator. What I'll say is just, you got a 5 and a 2. When you raise something to a power, you multiply them. So 3x minus 5 to the 10th, and stop there, right? You're definitely not multiplying that out. It's to the 10th power. You'd have to be crazy to try. All right, so how are we going to simplify this? Again, you could do a lot of factoring stuff out. I'm not going to do that yet, at least. So I'm going to collect the 7 and the 2 here. 7 and 2. And then we have negative 2x plus 4 to the 6th, 3x minus 5 to the 5, minus negative 2x plus 4 to the 7th. I should have figured out the constant to start with. So for the constant, I have a 3 and a 5, which is 15. So minus 15, and then minus 2x plus 4 to the 7th, 3x minus 5 to the 4. All over 3x minus 5 to the 10th. Now, something you can do here is, if you take a look, this oops, I did it again. Why? If you look at this denominator here, right, that's actually the same term that's here and the same term that's here. So you can cancel, like the smallest number there is 4. So we can cancel 4 of those. So we can just cancel 4 of the 3x minus 5s. So if you do that, this one's going to be gone completely. This one's going to go down to a first power because we canceled 4 of them. And then down here we canceled 4 of them. There was 10, so we're going to end up with 6. So what we're going to get there is going to be actually negative 14, negative 2x plus 4 to the 6th, 3x minus 5, minus 15, negative 2x plus 4 to the 7th, and there is no extra term on the end. And then in the denominator, 3x minus 5 to the 6th. Okay, so that's looking a little better. Then what I can do is I can say, well, there's 6 of these. There's 7 of them here. So I could take out 6 of them. And also there's a 14 and a 15, which will actually have nothing in common, so we won't do anything with that. So we can take out 6 of these though. Negative 2x plus 4 to the 6th. And then if we take out 6 of them, we're going to have negative 14, 3x minus 5. Whoa. And then we took out 6 of them, so we have minus 15, negative 2x. I believe that's plus 4. Over 3x minus 5 to the 6th. Now, if we want to finish this off, because we might as well, because we did this much work, what you would do is inside there, we can just multiply that all out. So like negative 14 times 3x is going to be, I believe, negative 42x. Negative 14 times negative 5. I don't know what 14 times 5 is. It sounds impossible. I think it's 70, but you know. 14 times 5, it is 70. Plus 70. Plus 30x from the next term. And then minus 60. 3x minus 5 to the 6th. So, keep copying it. What do we got? Negative 42x plus 30x is negative 12x. 70 minus 60 is plus 10. 3x minus 5 to the 6th. And all I think I can do now, I think I'm done, is I can take out, it looks like, I can take out 2. So I can go 2, negative 2x plus 4 to the 6th. And I took the 2 out of the last term, so then maybe I'll have 5 minus 6x. And I don't know why I changed the order except just to put the negative one second. The negative term second. All right. Okay. There you go. So that's a better answer than we would have way up here. But remember, technically, as soon as you take the derivatives, you're done. So like, you probably could have typed this or this into the computer and been okay. Okay on Newton, probably. But, you know, you can simplify it, so we did. How did they write it? They wrote it exactly the way that I did, except they took out a negative 2 instead of a positive 2 at the very end, which is, you know, fair, but I didn't. So I'm looking through these. Here's a real easy one. Well, I don't know. Is anything a real easy one? We already did one like this, but I'm just doing it for fun, right? So when you see this, right, and we want to find, of course, find h prime, remember what you're supposed to do with these. You're supposed to be thinking of the functions from the outside in. And remember, when you see a trig function to a power, it's actually like this, right? That's what you should think of. So even though it doesn't look like it, the outside function is actually the 6th power, and the secant is actually the inside function. So when you go to write h prime of x, the outside function is the 6th power, so it's 6 secant to the 5th x, right? Using the notation we have up there, and then times the derivative of what's inside. What's inside is the secant. So what's the derivative of secant x? You have to remember. Secant x, tangent x. Like that. So put it together, you have a secant and another secant, so it's actually 6 secant to the 6th x, tangent x. Interesting. But the key there is just knowing what the outside function is. And writing it like this really takes the mystery out of it. You could just do the derivative that way. That's too easy. Just going to skip all these easy ones because we're too smart. Oh, I like this one. I like this one. So we're going to do this one because I like it. We haven't really talked about fractions very much, but we could. Now, you can do quotient rule. That's fine. But you also can do chain rule. So we're going to do it with chain rule instead of quotient rule. What I'm going to do is, before we start, so this is just rearranging. We're not doing a derivative yet. We're just rearranging. So remember, when you have something to a power in the denominator, that's actually just a negative exponent. So this is really negative x squared plus x minus 2 to the negative 5 power, right? So that's not the derivative. But the easiest way to do this derivative is to write it like this first. Then you can say the outside function is the negative 5 power and the inside function is that little polynomial. So h prime is going to be, well, remember how it goes, derivative of the outside, derivative of the inside. So the derivative of the outside is negative 5, negative x squared plus x minus 2 to the subtract 1. So it's negative 5 minus 1 is negative 6. Easy to get that wrong. And then times the derivative of what's inside. The derivative of what's inside is going to be negative 2x plus 1. So you get this. And when you go to rewrite it, which you don't have to, but if you go to rewrite it, in the numerator, you're going to have this, right? There's no negative exponent there. So the negative 5 is in the numerator. And this is also in the numerator. So you have negative 5 parentheses negative 2x plus 1. And then in the denominator, you have this because it's a negative 6 power. So if you want to write it in the denominator, it's negative x squared plus x minus 2 to the 6th. And this is a perfectly fine answer. Okay? So you don't have to do the quotient rule on that because you can write it as a negative exponent. All right. So this is just like the table problem, but there's no table. So they say, but I want to do one because they just give you like, it looks like a string of numbers and it's confusing to look at. So they say let h of x equal f of g of x. They say if g of 3 is negative 4, g prime of 3 is 5, f of negative 4 is negative 6, f prime of negative 4 is 4, find h prime of 3. Okay, and you see how, I mean, it looks kind of like a mess, right? There's just so many numbers there, it's really easy to get confused. So the way to do it is to start with this. H, not h prime, h of x is f of g of x. So if you take the derivative, it's just going to be the chain rule, right? Like what's the derivative of f of g of x? It's f prime of g, g prime of x. Right, that's actually like that's the definition of the chain rule essentially. So we have that. Now we're supposed to be doing this to find h prime of negative 3. So h prime of, not negative 3, just 3. H prime of 3 means plug a 3 in for x. So you have to plug it in for the x there and the x there. So we have f prime g of 3, right? There's where we plugged it in. And then g prime of 3, there's where we plugged it in. Now what you got to do is work those out, because you've got g of 3 and g prime of 3. So you look these up in your list of stuff you know. So you have f prime of, what is g of 3? Right? You look it up, you find it right here. G of 3 is negative 4. And then you look up the other one, g prime of 3. What's g prime of 3? Well, g prime of 3 is right here. G prime of 3 is 5. So 5. But then you've got to look this one up. F prime of negative 4. Well, f prime of negative 4 is right here. So what are we going to get? Looks like f prime of negative 4 is positive 4. So it's 4 and then 5. Multiply those together, you're going to get 20. Now notice we didn't use every number. Like there was no, like we didn't use f of negative 4. Right? This one, we didn't use this one. It just wasn't necessary, right? It wasn't in the formula. So don't expect to necessarily use every number. Just like on the ones with the table, we didn't use the entire table. You just need to know which ones you need. Okay, it's another quotient rule. Blah, 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 blah. Simplified, factored form, they say. All right, so easy. All right, well, just looking at these, it looks like we definitely covered it all. So I am going to call that a lecture. Seems short after the 2-hour lectures I've been doing. So this is, yeah, so this is it. So I'm gonna upload this for you guys. Good luck with it. Initially it's confusing, but I think people get this right away. You probably want to kind of stick to this kind of numbering thing that I did here if you're having trouble with it, because that really does seem to help people. Just identify the outside and the inside functions, okay? And work through the examples. All right, I'll see you next time.